Hi, so we are going over example D, and this is in, I think it's lesson 4, but this is a question you asked about. So, so let's just walk through this super slowly. We're going to solve this one. We're going to move this minus 3 over to the other side so that we just have the root 5a plus 9 on the one side. So we'll do that by adding. And we get root 5a plus 9 here. Now the next step we're going to do is we're going to square both sides so we can get rid of the radical. At least we'll get rid of one of them. We'll get rid of the one on this side. Okay, this is a multi-step one. Now, what that means is that this becomes root 2a plus 3 times root 2a plus 3, because we're foiling it, or we're squaring it. And here we have 5a plus 9. So we'll just leave the 5a plus 9 first. Now, what we're going to do here is we're going to use FOIL. So first, outer, inner, last. So the first one is 2a times root 2a times root 2a. So that gives us just 2a. The outer is 2a times 3. So it's always coefficient times coefficient, radicand times radicand. So the 3 would be outside the radical and the 2a would stay underneath. So basically I'm saying I have 3 to root 2a's. Then we do our inner. So it's 3 times root 2a, so I have 3 root 2a's. If it helps to imagine, there's a little invisible 1 in front of the radical when you're multiplying. So basically you're multiplying that 3 times the 1. Then 3 times 3 is 9. That's our last term and is equal to 5a plus 9. So that's how we get these two middle terms there. When we're multiplying, and I'll do a little example on the side here. So it's always like if I have 2 root 3 times 3 root 2, we always I don't want to do that one. 2 root, let's make it a 7. It's always the two coefficients times each other, so 2 times 3 is 6, and then the two radicands times each other, so 3 times 7 is 21. So, and if there's no number in the coefficient, you imagine it to be a 1. Okay, hopefully that helps. So now we're going to finish this problem. So I might be doing it a little differently than I did it on the original video, but I'm just trying to expand it out totally. So we want to move everything over to one side except for the radicals. So on this side, I have 3 root 2a and 3 root 2a, so that's 6 root 2a. And I'm going to move everything else over. So I have 5a, and then I've got minus 2a, and then I have 9, and then I have minus 9. So basically, these I just moved from the other side here, okay, by doing the opposite operation. So 6 root 2a is equal to, well, 5 minus 2a is 3a. 9 minus 9 is 0. Now, we do have to square both sides again because we want to get rid of that radical. So we square both sides. And when we do that, so this is where it might be a little bit different from what I did on the video because I think I divided first. You still get the same answer. So here, this 2 applies to both those terms. So 6 squared is 36. And root 2a squared is root 2a. And on this side, 3 squared is 9, and a squared is a squared. Now I multiply this through, and I'm going to get 72a is equal to 9a squared. Now I'm going to divide both sides by 9, because I can. Let's make it simpler. So 72 divided by 9 is equal to 8. 8a equals, well, 9 divided by 9 is 1, a squared. So I'll have 8a equals a squared. Let's move everything over to one side. A squared minus 8a. So I can factor this, and I get a times a minus 8. So my roots would be a equals 0 or a equals 8. Okay, now remember, at this point, you need to verify, and I did that in the video, so these are the answers